Paolo, and I want to also thank Anna Guanini from the University of Bologna, who helped organize my visit, and also to Anna Giatti, who did all of the details. It is a great pleasure to be here at the Institute to speak about Nikola Tesla and to share with you some of the things that I learned in writing the book. The book came out in May of 2013, so just a few months ago. And in that time, I've had the opportunity to speak about the book to a variety of audiences, to talk about it on the radio in America. But this is the first opportunity to talk about it in Europe, and I'm very pleased to be here. It is also the first opportunity I have to really talk about Tesla, as the title says, as a pioneer of electrotechnia, of electrotechnics. Most of the talks are often to popular audiences who are very interested in Tesla, but they are often waiting for me to talk about Tesla the myth rather than Tesla the historical figure or Tesla the engineering figure. So today what I want to spend some time with you doing is to talk about Tesla as the technical figure, and in many ways focus on that particular thing. Naturally, if you have questions about his personality or his colorful life, I'm happy to take those, but I'm going to, in my remarks, focus on that. I want to apologize that the title there is as much Italian as I can do, and so I appreciate your patience with me in English, and I prepared the slides so that you can simultaneously both listen and see where I'm going. Now let me make sure that I advance this. Probably for an audience like this, I don't need to answer this question of why study Nikola Tesla. Many of you, from your own experiences or your education or your work in engineering, probably know that Tesla is an important figure because he worked on two key technologies. One was the alternating current motor, and he worked on that in the 1880s, and the other was the wireless transmission of power. He was a rival with Marconi in the development of what we would call today radio technology, but of course remember that radio is a word that is only introduced in about 1903 or 1904. The the publisher insisted that I give the book the title, Tesla, the Inventor of the Electrical Age, largely because Tesla is one of the few individuals who spans both power engineering and early electronics. Edison, for the most part, concentrated on power engineering, on electric lights, on applications of electricity that are part of what today we call the grid. And other people, such as Lita Forst or Marconi, were people that concentrated on what became electronics. Tesla is one of the few individuals who spans those two fields, and so that's the sense of why I called the book, or agreed with the publisher to call the book, Inventor of the Electrical Age. Now, in studying Tesla, there is an interesting opportunity that I had as a scholar, was that the approach that I wanted to take was to focus on telling the story of Tesla without having to resort to genius or luck. When you study where you're a biographer, as I am, and as Paolo mentioned, I did a biography of Elihu Thomson, and I've done a great deal of work on Edison and Alexander Graham Bell. So I'm a biographer primarily by trade. Now there, you quickly realize that there is an intellectual fork in the road that you have to just think about when you begin the study of an important individual like Tesla. And so you can go down one fork, which is to say, Tesla was a genius. He was brilliant. And how do we know he was brilliant? Well, look at all the inventions that he came up with. And as a result, you fall into a vicious circle. He was a genius because he had great inventions, and the great inventions show that he was a genius. And that doesn't do much for my way of thinking. It doesn't really explain anything. So that genius is one fork in the road. The other fork that you can go down is to talk about how inventors have a method or a style, that there is a particular way that they work, and that work, by carefully studying the surviving artifacts or the documentation or patent testimony, you can reconstruct something of the process by which they thought and acted on their ideas. And so I'm as I would say in American terms, I'm a methods guy. In other words, I focus on inventors having a method. And I was very lucky that when I came to Tesla, Tesla was not the first project that I worked on, but was really the third or fourth project. And I had gotten used to trying to figure out how to make sense of inventors, and was able to bring all of that experience of working on other topics to the task. Now, Tesla is special. He's special because he is a different sort of inventor than his colleagues, his peers in late 19th century Europe and America. He was not born in Western Europe or in Northern Europe like most of the people that shaped electrical engineering in the 19th century, but he was born in the Balkans, in Serbia, in 1856. And he comes from a very unusual background. His father was a priest in the Serbian Orthodox Church, as were many of his uncles. And he was steeped in a very particular philosophical, indeed Neoplatonist worldview that shapes much of what he does, and also results in making him very puzzling to other individuals that he encountered in America. He was certainly more theoretical and less hands-on than his rival Edison. And he also pursued a business strategy, which I don't think until I got into this work I really fully appreciated, which is his strategy, the way that he hoped to make money from his inventions was, and I have just the word promotion there, but it really had three parts. You basically patented it, you promoted it, and you sold or licensed the patents. So he really understood intellectual property, and in many ways, we can talk about this in the discussion, was somebody that anticipated much of the way that modern high-tech industry operates, that entrepreneurial startups today often worry about getting the intellectual property, selling the intellectual property to someone then who can exploit it. Most of the history of technology that has been written thus far about inventors focuses on the fact that, well, Edison made his money by developing a big manufacturing company, General Electric. Or we want to know how Alexander Graham Bell converted or shaped. And Tesla was driven by, not so much by science, but by the knowledge and by ideas rather than by markets. And that, I think, is another important feature that you'll see as we go along. In the book, I took an approach that built the story of Tesla around two big themes, and in particular, as Paolo told you, the book has a particular trajectory. And from the 1880s into about 1894, Tesla's career is a rapid ascent. It is a true, as we would say in America, rags to riches story. This is somebody who arrives in America in 1884 with perhaps a few pennies in his pocket. By 1894, he is the toast of the town. He is being given honorary degrees by universities. He is seen as the rival, if not the superior inventor to Edison. At the same time, by 1894 to 1904, his career begins to slip away and is not as successful. So the task for a biographer is to both account for the upward success and the downward slope to not so much failure, but to disappointment. And there I developed an idea in the book that there are two interacting themes. One is the ideal. Tesla believed that the way to develop an invention was to think about the invention, to discern the ideal, the perfect way, the Neoplatonic way, the essence of an electric motor or a circuit, and to think about it, and then think about it some more, and think about it for a few more days. It took him a very long time. He was as Alexander Graham Bell described himself. Bell said once, "I am a theoretical inventor," which means that Bell spent his time sketching notes and drawing pictures and thinking about how he wanted to develop a telephone or another device. And Tesla was exactly the same way. So the ideal is this perfect idea that you come up with first, and then you go and you realize it out in the material world. And so you can begin to see that Tesla was something of a Platonist. Now, unfortunately, if you are going to deal with entrepreneurs, businessmen, potential customers, they may not necessarily fully grasp this essential idea that you have for your invention. And so you have to tell them a story. You have to engage a value in their culture. You have to create some metaphor that captures their imagination and leads them to support and invest in your inventions. And that is what I mean by illusion. Now, let me be quick to say that I don't ever argue that Tesla was purposely going out and trying to deceive you and trick you into something. He was always looking for the best way to explain something. And the question then becomes, within this framework, did Tesla's illusions, his pursuit of these metaphors, these stories, these brilliant demonstrations, ultimately get in the way of fully grasping what he thought was the ideal for a particular invention? So let me talk first for a few moments, a couple of slides about the alternating current motor, and then tell you the story of what he did with wireless power. Tesla, I said a few moments ago, was born in what is today Croatia to a Serbian family, and his father thought that he should go on and continue into the priesthood like everyone else in Tesla's family. And Tesla got quite sick at the end of his time in high school or at the gymnasium, and while he was recovering from this illness, his father said, "If you recover, you can do anything you want." And Tesla said, "Well, to tell you the truth, what I really want to do is I want to go to," he didn't say engineering school, but he said, "I want to go study science and mathematics." And so his family arranged for him to attend the Johannem Polytechnic School in Graz, Austria, which was also founded by an Austrian Archduke, Johann, and was about, I'm going to say, founded in about 1820. So maybe there is probably some interesting parallels between this institute and the Johannem Polytechnic, which of course is the technical university today of Graz, and a very fine institution. While he was there, he began thinking about electric motors, and in 1881, having dropped out of school and walking in the park on a lovely evening in Budapest, he has the vision that he should develop a motor that was going to be sparkless, that was going to eliminate having the commutator, which was the Achilles heel, the weak link in all direct current or alternating current motors up to that time. And this is before they had carbon brushes or knew how to exactly proportion the commutator in the motor. So he works for a couple of years for the Edison companies. First, an Edison operation in Budapest, which was installing one of the first telephone exchanges in the world. He then moves to Paris, works on the Edison electric lighting, the incandescent lighting systems. That takes him all over Europe. I'm not sure that he necessarily got to some of the Edison installations in Italy at that time, but he certainly went all over. He was in Strasbourg, he went into Germany, he went all over France. And in 1884, he finally is brought to New York, and he arrives in New York with one of my favorite stories is he has a letter of recommendation in his pocket, and the moment comes that he approaches Edison, and he hands the letter over to Edison, and the letter is not from Charles Batchelor, it's from Tivadar Puskas, who was his patron in Budapest. And the letter says to Edison, "Dear Mr. Edison, there are two great men in the world. You were one, and the young man standing in front of you is the other." So I've always wanted to, be able to write a letter of recommendation for one of my students along those lines. So in 1884, he's working for the Edison company. He works for the Edison company only a few months, less than a year. He, as near as I can tell, probably only interacts with Edison 2, maybe 3 times in the entire period. He's a low-level engineer in the organization. He develops for Edison an arc lighting system, which the Edison company, for strategic reasons at that point, decides not to install. And so Tesla, not expecting that he was going to be rewarded for this or that the technology was going to be developed, walks off in a huff. He says, I'm gone. And in fact, there's a notebook in the collections in this Tesla museum in Beograd where the last page of the notebook says in big scrawl, "Goodbye, Edison." And off he goes. He goes to, teams up with a series of other businessmen in a town not far away from New York City, Rahway, New Jersey, where he patents all of the ideas that he got while he was working for the Edison organization. So lest you get hung up on the fact that Edison stole things from Tesla, you need to pause and think about that in this very crazy world of electrical technology in the 1880s. Tesla may have been appropriating information or IP, intellectual property, that he had would really actually belong to the Edison company. So I always have a problem with people sort of say, well, Edison stole everything from Tesla, and he tried to keep Tesla under his thumb, and all of this makes me very, very impatient. In the company in Rahway, New Jersey, does not succeed. I put on this particular slide a patent from one of Tesla's arc lights, because Paolo is going to treat us to a demonstration of an arc light after the symposium today. But in 1886, Tesla is, after working for a period of time as a ditch digger in New York City, connects up with another set of business partners, a man named Charles Peck, another man named Alfred Brown, and they basically support Tesla in the development of the alternating current motor. I always think about the fact that Peck was a very successful businessman, and he worked in the telegraph industry. He indeed outsmarted Jay Gould. Jay Gould at this point was not only the great robber baron who controlled railroads, but he had also decided to steal the telegraph business away from the Vanderbilt family, and he basically captured Western Union in the mid-1880s. So Peck, realizing that the Western Union was going to continue to expand, essentially created a paper corporation called the Mutual Union Telegraph Company, and sold it eventually for a handsome profit to Jay Gould. And so Peck had a small fortune and decided to invest it in Tesla. And the particular project that they had Tesla go forward on was to develop the first practical alternating current motor. Now, as I mentioned, I want to talk about Tesla's style as an inventor, his method. He often operated, as we would, to use perhaps a more popular informal word in America, like a maverick. He was somebody who would go in the opposite direction of the prevailing thinking in electrical technology at that point. All electric motors essentially work because they have two pairs of magnets. One set of magnets stays still or stationary, they're called the stator. Another set of magnets rotates, they're called the rotor. Up to this point, whether we're talking direct or alternating current motors, everyone changed the magnetic field in the rotor. And Tesla's big insight is you can get rid of the commutator, you can make a sparkless, a more efficient motor by changing or altering the magnetic field, not in the rotor, which was what everybody else did, but in the stator, in the stationary coils. So in this diagram, what he did is this is a generator over here. These are slip rings. This is an alternating current generator. This is this donut, the round thing. The torus is the stationary magnets. And this piece right in here is the rotor. Now, if you feed, as it says here, two alternating currents into those four coils, and they're 90 degrees out of phase, or 90 degrees out of phase, then you can basically create a rotating magnetic field. In other words, the rotating magnetic field starts up, it's north here, and then in a few moments later, it's north here, and it keeps going around. That induces a magnetic field in the rotor and causes the rotor to spin. Okay, so an incredibly simple design for a motor. Okay, and it allowed electricity to move from being just used exclusively or primarily in the 1880s for electric lighting to the ability to use electricity for not just lighting, but for power applications as well. Now, Tesla's backers sort of said, this is a great idea, we need to get this invention out there, so they hired the very best patent lawyer in New York City at the time. They arranged Tesla to be interviewed by the press, they arranged for lectures, and they got Tesla working on creating a set of illusions, a set of very positive messages about the motor, and as a result, with, again, the help of his backers, Tesla sold the patents to the Westinghouse Company in 1888. Now, Tesla worked for Westinghouse. I always like to say that Tesla probably had more great jobs than we will ever have. I mean, he works for Edison, he works for Westinghouse, he never stays very long. Again, he's only at Westinghouse for perhaps 8 or 10 months. And he decides in 1889 that he has done everything that he's going to do for Westinghouse in terms of improving or patenting his motor, and he leaves it to a team of engineers at Westinghouse, very talented people such as Charles Scott and Benjamin LeMay, to figure out how to actually get this thing to become a practical product. And it takes those engineers at Westinghouse on the order of 5 or 6 years to convert the idea of a motor with a rotating magnetic field to being a practical industrial device. So, bored with what he was doing at Westinghouse, in 1889 he basically buys himself a ticket. Now there he runs into a graduate student who is studying physics and is on his way to a postdoc with Heinrich Hertz. And so the graduate student tells Tesla, while they're at the World's Fair, all about what Hertz is doing and how Hertz has actually done the experimental work to detect electromagnetic waves. And Hertz used an apparatus that you probably have seen variations of here. We may even have, I know we have some of the spark, I noticed the spark gaps in the next room. Now, the reason why I show you that particular diagram is Tesla saw this apparatus, came back to New York, and he repeated Hertz's experiments and designed for himself what became known as the Tesla Coil. The Tesla Coil is essentially a very sophisticated, but nonetheless reworking of the Hertz apparatus. And Tesla was able, by carefully taking advantage of resonance, and resonance was the ideal behind all of his work with radio. That was the thing that he kept coming back, and he thought about, how can I use resonance? How can I take advantage of electromagnetic resonance? How can I get all of the parts in this circuit to be optimally structured so that I get the maximum high voltage, high frequency out of it? And so he's basically, the Tesla coil, for another thing for which he is very famous for, the way Tesla developed that was, as I say, souping up the Hertz apparatus. By the way, and it's an interesting story in itself, in another trip in 1892, Tesla goes back to Europe, does a series of brilliant lectures in London and Paris, has a side trip back to see his family in Serbia, and on his return, he stops in, I believe it's at that point, Hertz is at Bonn, and he has to stop and tell Hertz that Hertz doesn't understand electromagnetic waves. Needless to say, there's no mention in the Hertz diaries, which were translated some years ago into English, about this visit from this very strange American who was telling him, Tesla was telling Hertz that he was completely wrong.